All right, mathletes, here we are talking about tangent ratios. So the big thing we want to remember is with tangent ratios that we're going to have that the tangent of some angle is going to be its opposite side over its adjacent side of that angle. There's three trig functions that we'll be learning here in geometry. One is sine, one is cosine, and today's is tangent. So I bring up these two that we'll look at our next two lessons to help us understand and use an acronym that can be useful for remembering these trig ratios. So the acronym is SO, CA, TOA. Okay, SOHCAHTOA. SOHCAHTOA, it sounds um, will tell us which trig function deals with which ratios. So as we're talking about tangent today, or TOA, that reminds us that tangent is the ratio. The first letter, O, represents the numerator of the ratio, and adjacent, represents the denominator of our ratio. Okay. The other thing that we want to bring up now is the use of our calculator. So when we say tangent of A, these are all saved in our calculator. Okay. We use special right triangles to look at some of those and deduce those, but that was only for angles of 45, 30, and 60. So tangents, okay, are all saved in your calculator along with sine, cosine, as well. So when you look at these three trig functions, identify where you can find them on your scientific calculator. Okay, so just like measures have a different unit. Sometimes we measure things in metric using centimeters and meters, and sometimes we use standard units looking at like inches and feet. Angles are also going to have two different ways that we measure them. One way is degree, which we should be familiar with, and the other one's radians. Radians we won't deal with here in geometry, but definitely will come up in trigonometry type classes. Okay, so what we have to make sure is that our calculator understands what mode we are dealing with. So make sure when you go up to mode in your calculator, you should check this and make sure that you have it highlighted as degree and not radians. If you don't have a calculator that's a graphing calculator and you want to check to make sure it's in the right mode, an easy way to do so is just go ahead and click your tangent and type in 45 degrees. And if you get tangent of 45 degrees and that is equal to 1, then you know your calculator's in the right mode. If you can't problem solve in getting your calculator in the right mode, make sure you stop by office hours and I can help facilitate that. Okay, so let's look how we're going to use tangents to solve some problems. Okay, so in this first example, we want to find the tangent of S. Okay, so notice that these tangent ratios are dependent upon the angle we're talking about. So our side length, or our angle S here, okay, so the tangent of S is equal to our opposite side over our adjacent side. So I'll use those as our abbreviations. Sometimes I'll just be as simple as O and A. So when I do this, to make sure I set this up right, I got to identify the sides of my triangles. We talked about it briefly in previous notes, but we need to look at our angle S and understand that 18 is our adjacent side. So again, I'm just going to use A. And 80 is the opposite side of my from my angle S. Remember, when you're taking your adjacent side, make sure the adjacent side you're looking at is not your hypotenuse. We always know our hypotenuse is across from our right angle. Okay, hypotenuses will only be used with our cosine and sine ratios. Okay, so now that I've identified my opposite and adjacent sides, I can substitute those in and I get 80 over 18. So as I rewrite this, I can say tangent of S is equal to 80 over 18. And that as a decimal is 4.4, repeating. Okay. Next thing is it wants us also to find tangent of R. Remember, it's not dependent upon the triangle, but the angle that we're talking about. So this angle R is over here. Okay. Well, the hypotenuse is still 82, but notice as I talk about the adjacent side, the side next to angle R, that is my side of 80. And the side that is now opposite of my angle R is my side 18. So as I write my tangent of R, that is equal to the opposite of R, which is 18, and my adjacent side, which is 80. So as I simplify that and get a decimal, I will see that I get 0.225. Okay. So in our next examples here, we want to be able to solve for a value. So this is really with the power and where we'll see trig ratios being used the most. Okay. So since I know I have a right triangle and that all 32 degree right triangles are going to be similar, I have those values and those ratios saved in my calculator. So if I want to use, so we're given 32 degrees, and I want to identify my side lengths. So what's next to 32 degrees? Well, X, that is my adjacent side. So I'd label my sides an A, O, or an H. And now I look at 11, and 11 is opposite of 32, so that's my opposite side, or it's across from. Okay, my hypotenuse is over here. It's not important to me right now because it's neither a side I know or a side I'm trying to find. So now that I've identified that O and A are relevant to the problem, that leads me down the road of knowing that it must be tangent. So if I do tangent of 32 degrees, okay, that's my opposite side over my adjacent side. So now as I solve this out, I think the easiest way to recognize this as proportions. So think of similar triangle stuff, and we'll use our strategies from that chapter. So if I put that over 1, I have two ratios that equal to each other to form this proportion. And to solve these, I'm going to cross multiply. So I'm going to do x times tangent of 32 and do that cross product. Well, x times tangent of 32, it's a variable, so I'm just going to leave it as that. And 1 times 11 is 11. Well, I could type in tangent of 32 at this point, but I'd rather wait until I have x completely by itself. So since I have multiplication happening here, to undo multiplication, I'm going to divide by tangent of 32 on both sides in order to get x by itself. So now I have left x is equal to the 11 divided by tangent of 32. So in order to get my decimal and my actual measure of that, I'm going to use my calculator. Okay. And I'm going to turn it on and do 11 divided by tangent of 32. Okay. And as I hit enter, I can get to the nearest tenth. So I'm going to get 17.6 as my value for x. Okay. So in our next example, we want to kind of tie in this idea of special right triangles that we talked about before. Special right triangles helped us build this idea of our trig ratios, but it's just a kind of shortcut for angles of 60 degrees and 30 degrees. So for that triangle, we knew that this side was x, this side was 2x, and this was the square root of 3x for that 60, 30, 90 special right triangle. So if I want to do the tangent of 60 degrees, I'd identify my angle here. So my tangent of 60, remember tangent is your opposite over adjacent. So as I look at my triangle, my opposite side, okay, is square root of 3x over my adjacent side, or next to, which is x. Remember, it's next to, that's not the hypotenuse. Okay, and 2x is the hypotenuse for that special right triangle. So as I look at this, I notice is the x's will cancel out. So I can see that the tangent of 60 degrees is equal to the square root of 3. I can go through and verify this with my calculator. So notice that the tangent of 60 degrees is that value. Okay, so that's how we would use our trig function. It's saved in there. But special right triangles, we know that that's the same value as square root of 3. Okay, so as you're dealing with special right triangles that have measures of 60, 30, or 45, you can use your special right triangles, or if you prefer just to use your trig ratios, you can do that as well. Okay, so here are some other examples I'd like to walk through just to kind of help us with these. Again, first thing I'm going to look for is my angle that I know. I know that this is 61 degrees, 90 degrees. These trig functions only work with right triangles. Okay, so of 61 degrees, the side I want to know and find is my adjacent side, and 22 is my opposite side. Since I'm dealing with O and A, I need to use my tangent, and tangent of 61 degrees is equal to the opposite side over our adjacent side. Now, as I solve this, I'm going to put this over 1. Doesn't change that value. Doesn't change any value when you divide it by 1. And then when I do my cross products, so I'm going to get x times tangent of 61 equals 22 divided by tangent of 61 divided by tangent of 61. As I type that into my calculator, I'm going to get a value, and we want to round to the nearest tenth. So I get x is equal to 12.2. Okay, it was 1/9, so nearest tenth, I'm just going to round it up to 12.2. Okay, so in my next example here, in B, again, identify my angle of 56 degrees. I see it's a right triangle, so I can use trigonometry. So x is opposite of my 56 degrees, and 13 is my adjacent side. Okay, so now that I have labeled those, I can set up and say, okay, O and A, that deals with tangent. So tangent of 56 degrees is equal to the opposite side over the adjacent side. Okay, now to solve, I'm going to put this over 1. Do my cross products. 1 times x is x equals tangent of 56 times 13. So as we're here, x is already by itself. X times 1 is just x. So that ends up being a point at which I'm going to now just type into my calculator. So make sure you close off your parentheses. This argument of the trig function shouldn't be multiplied by 13, but it's the entire part here that is being multiplied by 13. So I see tangent of 56, close my parentheses, times 13, and I'll get a value of x being equal to 19.27, so rounded is 0.3. Okay. So in our final example is going to be a word problem here. So we're trying to measure this height of the spruce tree. Okay, at 45 feet away from the base, you measure the angle of elevation, okay, from the ground to the top of the tree to be 59 degrees. So if we want to find this height of the tree, okay, to the nearest foot, okay. So again, when I'm looking at 59 degrees, I see a right angle, so I can use trigonometry. The side I'm trying to find is opposite my angle. The side I know is my adjacent. So since we're dealing with opposite and adjacent sides, I know I can use tangent. So tangent of 59 degrees is going to be equal to the opposite side, h, over my adjacent side, which is 45. So I do that substitution. Now that I'm there, I'm going to put that over 1, and I'm going to solve for h. So using my cross products, I get h is equal to tangent of 59 times 45. So tangent of 59 times 45. I'm going to see that h, and I'm rounding to the nearest foot, so it's 74.89. So that's going to round, and I'm going to put a little approximate to 75 feet, making sure I have my units when we're dealing with word problems. Okay, that concludes our notes today on trigonometry. Please stop by office hours if you have any questions. Make sure you understand tangents before we start talking about sine and cosine, because as we're dealing with the three of them, we're going to have to now decide on when we're going to choose sine and cosine. So if you understand tangent, it'll be a lot easier to make that transition.